Section 4.5 is Rules of Exponents. I can multiply and divide powers. Notice what happens when we multiply two powers with the same base. So here, a to the fourth is really a times a times a times a. Base times itself, exponent number of times. And a cubed is actually a times a times a. Base times itself, exponent number of times. If I were to simplify this down, my base is a, 1, 2, 3, 4, 5, 6, 7 to the 7th power. That's the same, guys, as if I would have taken a to the 4 plus 3. I'd have kept my a. 4 plus 3 is 7. So when we multiply powers with the same base, we can add our exponents. So as long as we have an a and an a, for example, we can add those exponents and get to the same spot we would have been if we'd have written them all out. And that's one of our properties here. So the product of powers property says to multiply powers with the same base, we add their exponents. So keep your base, add the exponents. 4 cubed times 4 squared equals 4 to the 3 plus 2 power, or 4 to the 5th power, for example. Lake Powell, the reservoir behind the Glen Canyon Dam in Arizona, can hold about 10 to the 12th cubic feet of water when full. There are about 10 to the 27th water molecules in 1 cubic feet of water. About how many water molecules can the reservoir hold? So, if there are 10 to the 12th cubic feet of water, and each one of those has 10 to the 27th molecules, we can multiply those together. When we do that, since we have the same base, we keep our base and we add our exponents. So 12 plus 27. Again, that base is the same, and we get to the 39th power, and that's how many molecules. So 10 to the 39th power molecules. Go ahead and pause here and give these a try. We're going to find the product, write our answer using exponents. So 2 cubed times 2 squared. I have the same base here, so I keep my base. I go ahead and add my exponents. So I take 3 plus 2, which gives me 2 to the 5th power. And we want it with exponents. We don't want to simplify that to be 32. We want it with the exponents, so keep our base. Give 2 a try. Here, we have the same base, so I keep my base. And since I'm multiplying, I can add my exponents. 7 plus 5 means I'm going to get 8 to the 12th power. Give 3 a try. Here, when I don't have an exponent shown, remember that my exponent is a 1. So, my bases are both 5s. I can keep that base. And here I can add my exponents. So I take 5 to the 1 plus 2 power, which gives me 5 cubed. Give 4 a try. It doesn't matter how many things that we're multiplying as long as they have the same base. So here, since my bases are all 4s, I can keep that base. And since we're multiplying between all of them, I can add all my exponents. So I can take 6 plus 4 plus 3. It's going to give me 4 to the 13th power. It works the same way here in A. Even though my base is an x, it's still the same in both cases. I'm multiplying, so I can add those exponents. 6 plus 9 means I'm going to have x to the 15th power. Here, we can think about these all in terms of their own individual multiplication. So 3 times x times 5 times x to the 5th power. If we look here, our coefficients are 3 times 5, which is 15. My variables have the same base, x and x. So I'm going to keep that x. Remember, my exponent is a 1 if there isn't one shown. And when I'm multiplying powers with the same base, I add those exponents. So 1 plus 5, which means I'm going to get 15 times x to the 6th power. There is a related rule we can use for dividing powers with the same base. So here, a to the 5th power is the same as a times a times a times a times a, divided by a squared is the same as a times a. We know that anything divided by itself is 1. So a divided by a is just 1. A divided by a is just 1. And then what I have left is a times a times a. If I simplify here, 1 times 1 is just 1 times anything is itself. A times a times a is a cubed. That's the same thing we would have gotten is if we'd have taken our base and subtracted our exponents. 5 minus 2 also would have given me a cubed. So that leads us to our quotient property of exponents. To divide powers with the same base, subtract the exponents of the denominator from the exponent of the numerator. So a to the m divided by a to the n, as long as they're the same base, we can subtract the exponents. Same thing here, 6 to the 8th power divided by 6 to the 5th power. I subtract those and I just get 6 to the 3rd power. So in example 3, here my bases are both 7s. So I keep my base, and when I divide powers with the same base, I subtract my exponents. I like to think about it as 6 minus 2. If we just use that little portion of our fraction bar, it looks like a subtraction sign. So I'm going to subtract them here. 6 minus 2. So again, my base stays, and I get 7 to the 4th power. Here, I have 4 times x to the 8th power over 10 times x squared. I'm going to treat these as two separate pieces. I'm going to work with my coefficients like one fraction. So between 4 and 10, my greatest common factor is 2. So I can divide each of them by 2 to reduce that fraction. And I'm going to end up with a 2 in my numerator and a 5 in my denominator. Now, dealing with my variables, they're both x's, so I keep it an x, and it goes in my numerator. I subtract my exponents, so I get 8 minus 2, which is going to give me 2x to the 6th over 5. Feel free to pause here and give this a try. Find the product or quotient, write your answer using exponents. So here, my base is the same, so I keep it. And because I'm multiplying, I can go ahead and add those exponents. So 7 plus 2 is going to give me b to the 9th power. Try 6. Here, all my bases are the same, so I keep my base. Remember, if my exponent isn't shown, it's a 1. I'm multiplying, which means I can add my exponents. So here I take 1 plus 5 plus 2, and I get a to the 8th power. Give 7 a try. Here, our coefficients are just being multiplied. So it's 2 times n to the 11th power times 6 times n to the 8th power. So we can think about all of these like individual factors. My number parts, I can go ahead and just multiply. 2 times 6 gives me 12. Then I look at my variables. Here I'm multiplying powers with the same base. These are the powers because they have the exponent on them. The 2 and the 6 are just a 2 and a 6. So I keep that base. And because I'm multiplying, I can add my exponents. So I can take 11 plus 8, which is going to give me 12 times n to the 19th power. Give 8 a try, please. Here I have 2 times m to the 4th times 7 times m to the 5th. Don't forget that those coefficients are just being multiplied, so we can treat them like their own individual factors. 2 times 7 is 14. I'm multiplying powers with the same base, so I can keep that base. And these are the powers because they have the exponents. I can add those exponents because I'm multiplying my powers with the same bases. So I can take 4 plus 5 here, which is going to give me 14 times m to the 9th power. Give 9 a try. Here we're dividing, but my bases are still the same, so I keep my base and I look at my operation. Since I'm dividing, I can subtract my exponents. 9 minus 4, and I get 6 to the 5th power. Give 10 a try. Again, I have the same bases, so I keep that base. Since we're dividing powers with the same base, we can subtract our exponents. 11 minus 7 gives me 10 to the 4th. If you're unsure which one's which, think about it like this. When we multiply, we make numbers bigger, and when we add, we make numbers bigger. When we divide, we make numbers smaller, and when we subtract, we make numbers smaller. So multiplying and adding go together, dividing and subtracting go together. Give 11 a try here. My bases are the same, both z's, so I keep it as a z. I'm dividing powers with the same base, so I subtract my exponents. 8 minus 3. And I get z to the 5th power. And in 12. Remember, our coefficients are just being multiplied. They're their own factors. So I'm going to split off my numbers as their own fraction here and work with them individually. Between 12 and 8, 4 is my greatest common factor. So I can take and divide my numerator by 4 and divide my denominator by 4, and that's going to give me my fraction in lowest terms, 3 over 2. Now, my bases are the same in these powers, which means I keep that base in my numerator and I subtract my exponents. Numerator minus denominator. This is going to give me 3n cubed over 2 as my simplified form. Here in number 4, we've got kind of a lot going on. I have a 3 times m to the 5th times m squared divided by 6m times m cubed. So I'm going to simplify my numerator first because that's where I have powers with the same base here to start with. So I can keep my base, add my exponents. 5 plus 2 is 7. And here I did not change my 3 or my 6m cubed. All I did was combine those two m's. Now I just have one thing left, division. So I can go ahead and treat my coefficients as one fraction. 3 over 6, I can take each of those. My greatest common factor here is 3. So divide them both by 3, and I'm going to get 1 over 2. My bases are the same, so I can subtract my exponents, keep it in my numerator, and I get 7 minus 3 as my exponent. 1 times anything is just itself, so we get m to the 4th over 2. You can keep the 1 there if you want to, but we don't need it. So again, just like when we solve equations, we check to make sure the left side is simplified and the right side is simplified. Here I checked to make sure my numerator was simplified and my denominator was simplified. My numerator wasn't, so I went ahead and did that first, and then moved to my division. And I will finish this section up in another video.